Hi, everyone. I hope you had a great ending result from your engineering design challenge. And you'll see later on that one of the opportunities afforded to you by doing this engineering design challenge is that you find out that failure is not terminal, and it actually can help you out. So I'm sure a few chuckles will happen, hopefully, as you get through this. As I go through today's presentation, I'm going to emphasize interdisciplinary connections and doing that through the technology and engineering focus in technology and engineering education through STEM. So it's my pleasure to have this opportunity to talk with you today about technology and engineering as a part of your school's efforts toward integrating them through interdisciplinary instruction. ITEEA, the International Technology and Engineering Educators Association, embraces the concept that technology and engineering bring STEM to life. So instead of just having the S and the M, that T and the E can really bring a context that captures the essence of interdisciplinary team instruction, or STEM instruction, focusing on the integration of science, technology, engineering, and mathematics, while using technology and engineering as a catalyst to engage students in meaningful real-life contexts is the key to taking this curriculum to its highest level. These technological and engineering contexts bring attention to the increasingly important role that STEM plays in our society and emphasizes how it affects our everyday existence. Technology and technological literacy have been described in many ways. Most definitions concur technological literacy is used to make our lives better, more productive, or more enjoyable. In itself, technology can be rigid and inhuman. It offers no solutions. However, when managed, technology is flexible. When understood, it can be adapted and changed as needed or wanted. Many educators think of technology and technological literacy as applied mathematics and science for specific purposes. The purposes have also been described as the use of knowledge, tools, and skills to increase our potential, to solve problems, and to modify our world. The issue is not whether technology or engineering is good or bad, not whether it should or shouldn't be offered, or how it should be taught. The pertinent issue here is whether any nation can maintain a worldwide competitive edge without appropriate understandings and education pertaining to technological literacy. Therefore, the information being shared today in this presentation will help you to understand this process more intimately, and it's an imperative that our students are given the opportunity to connect the content they are learning through the academic core subjects and the arts, as well as outside learning experiences in rich and meaningful ways. Using an integrative STEM delivery through interdisciplinary instruction is a vital key to unlocking a unique learning experience that children will experience and apply in circumstances beyond the classroom and hopefully long into their future. Focusing on the T of STEM and defining technological teaching, educators often only associate technology and technological literacy with use of computers and educating with technology, instructional technology. Technological literacy, however, is teaching about technology and all the components related to it. We must consider all types of technologies that relate to our designed world. That designed world may include medical, agricultural, related biotechnologies, energy, power technologies, information, environmental, communication, transportation, manufacturing, construction, and more. And I'm sure all of you just memorized all of those as I said them. Really, it's everything in and about our world. To only think of technology in terms of delivering instruction is a narrow and short-sighted instructional delivery view. Technological literacy has its own content base. That content base has to do with the nature of technology, technology in society, design, abilities for a technological world, and the design world. At ITEEA, we're big on acronyms, like everybody else in education, and we love to use the TIDE acronym, Technology, Innovation, Design, and Engineering. As we move forward, technology and engineering bring STEM to life, and it provides opportunities to learn about the processes and knowledge related to technologies that are needed to solve problems and extend human capabilities. Science education does not automatically teach about technology any more than technology and engineering education automatically teaches about science. The subjects have distinct differences in their way of thinking, the content being addressed, and their importance as a general background for all students. It's important as you work through your conference, and I'm sure you understand that interdisciplinary instruction is not something that just happens. It has to be well planned, well thought out, and not just rolled out, but thoughtfully implemented. And as we move into teaching about technological literacy as that key in the STEM component, it's very important that we identify the interdisciplinary connections that happen in real-world problem solving through things such as literature, language arts, reading, writing, math, science, social studies, the ability to connect it to the arts, and so forth. We see the subjects working together to create an education that will produce the next generation of technology and engineering thinkers in order to benefit 100% of our citizenry. ITEA has used these foundational ideas as launching pads in a separate but interdisciplinary subject in our schools, starting at the earliest level and continuing through high school. The curriculum was developed as a result of several steps that included a major national project for the Standards for Technological Literacy, content for the study of technology. As we move through, we've identified through our STEM Center for Teaching and Learning a curriculum titled Engineering by Design. And if you look at engineeringbydesign.org, all one word, in your URL, engineeringbydesign.org, it's built on the Common Core state standards at both the high school and middle school levels, as well as standards for technological literacy, principles and standards school mathematics from NCTM, Project 2061 from the AAAS, American Association for the Advancement of Science, and has plans in place by the end of this summer to be connected and aligned with a matrix sixth generation science standards. Additionally, the program K-12 has been mapped to the National Academy of Engineers Grand Challenges. And I just found out today, down at the building, that North Carolina has the only high school in America that is totally based 100% with all of their instruction around the grand challenges from the National Academy of Engineers. I'm not even sure of the high school's name. I just found out about it today, but they made a big showing of it when I was down at the Rayburn building earlier today. So you should be proud of that. Using the constructivist model, students participating in the program learn concepts and principles in authentic problem-based learning, and through an integrated STEM environment, Engineering by Design uses all four content areas as well as English language arts to help students understand the complexities of tomorrow. EBD, as I was stating, is linked to the grand challenges for engineering, and these provide students with engineering issues, real-world problems and challenges. The vision for us is for this Engineering by Design curriculum to teach children how to design solutions under constraints. There are 7 resources that are available under constraints to solve every human want, need, challenge, and opportunity. Those are tools and machines, materials, information, people, capital, energy, and time. With those 7, though, comes constraints. You never have enough time, you never have enough capital, you never have enough tools and machines. And as we work through this, it's important that we give children the opportunity to practice that problem solving, even at the kindergarten and preschool age, as they work through, so that we teach them about the little e in engineering. That little e, engineering, we use it as a verb, teaches about engineering through design improves life. Technology and engineering have affected and continue to affect everyday life. And it's important that students see this in a variety of contexts. Technology drives invention and innovation and is a thinking and doing process. Technology and engineering are the basis for improving the past and creating the future. And technology and engineering are inquiry, design, and systems thinking to produce solutions. As we move through our curriculum from K to 12 with Engineering by Design, we focus hard on trying to make sure that an interdisciplinary connection is made and thoughtfully connected to each of the disciplines so that children understand their learning can be applied in a variety of contexts. One area that I thought I'd share with you is an area called co-curricular activities in STEM. I'd like to identify a new area that the Technology Student Association offers called TEAMS, Tests of Engineering, Aptitude, Mathematics, and Science. And in my opinion, it gives you an opportunity to connect directly disciplinary way with something that students can excel at. This one-day competition is an opportunity for middle and high students to apply their knowledge of STEM to a real-world engineering challenge. The 2014 competition theme on the Academy of Engineering National Challenge is Restore and Improve Urban Infrastructure. The team's competition specifically targets those interested in pursuing engineering as a career. Students compete in teams of 4 to 8 and work to define solutions that face engineers every day. The competition highlights the application of math and science to these real-world issues. I share this with you in summary to say that it's important to engage children early and often, and as children move through the grade levels, everyone sees the research, I'm sure you're aware of it, that many students become disengaged as they move through schooling, and mostly because they're not connected to the learning in terms of a real-world context. These kinds of co-curricular opportunities provide that. As you work through your Summer Institute, one of humankind's biggest challenges is to make our world work in a way that sustains everything that is wonderful about this planet. To do so will take a special kind of skill. Some call it design and technological problem solving. It is real solutions for the real world, and we say technology and engineering bring STEM to life. I want to thank you for this opportunity, and I wish you success with your efforts to improve your ability to teach STEM through an interdisciplinary approach, and hope that we can continue our conversation in the future. Thank you very much.